In this video, we will be going over the properties of logarithms. Logarithms have properties that are very useful in applications and higher mathematics. The properties of logarithms come from the properties of exponents. We start with the product rule for logarithms, so let x, y, and a be positive real numbers where a is not equal to 1. Then the log base a of x times y can be expanded to log base a of x plus log base a of y, where we can write the log of a product as the sum of logs of each factor. Let's try an example of this property. We want to rewrite each logarithm as a sum of logarithms by using the product rule, and we can use the product rule because we have a product as the input of the logs. So log base 6 of 4 times 7 is the same as log base 6 of 4 plus log base 6 of 7. And this log is simplified as is since there is not a power that is an integer that we can raise 6 by to get 4. And the same follows for the other log. So our expression is simplified as is. To expand log base 4 of 16 times x, we can use the product rule to rewrite this as log base 4 of 16 plus log base 4 of x. And we can simplify log base 4 of 16 since we can raise 4 by a value to get 16. That value is 2. And for the last example, the product rule can be applied for multiple factors in the input of the log. Here we have 3 factors. So log of 10 times x times y can be expanded as log of 10 plus log of x plus log of y. And we can simplify this logarithm since the base of 10 and the input are the same. And the value that we raised 10 by to get 10 is 1. So we can use the product rule for logarithms in the reverse direction too. If we start with the sum of logarithms, we can condense it back to a single logarithm. For example 2, we want to write each logarithmic expression as a single logarithm. We will be using the product rule in reverse to condense the logs. So log base 8 of 5 plus log base 8 of 3 can be rewritten as log base 8 of 5 times 3, or log base 8 of 15. And this log is simplified as is since there is not a power that is an integer that we can raise 8 by to get 15. For log of 7 plus log of x, we can rewrite this as a single logarithm as log of 7 times x. And for the last example, we can rewrite it as a single logarithm as log base 3 of x times x plus 4, which simplifies to log base 3 of x squared plus 4x. The next property is the quotient rule for logarithms. So let x, y, and a be positive real numbers where a is not equal to 1. Then log base a of the quotient x over y can be expanded to log base a of x minus log base a of y. So basically we can write the log of a quotient as the log of the numerator minus the log of the denominator. Okay, so let's try an example of this property. We want to rewrite each expression as a difference of logarithms by using the quotient rule for logarithms. And we can use the quotient rule because we have a quotient as the input of the logs. So log base 7 of 3 over 10 expands to log base 7 of 3 minus log base 7 of 10. And this log is simplified as is since there is not a power that is an integer that we can raise 7 by to get 3. And the same follows for the other log. So it is simplified as is. For the next expression, we can expand it to log base 3 of 81 minus log base 3 of x. Log base 3 of 81 can be simplified since we can raise 3 by a value to get 81, and that value is 4. We can also write a difference of logarithms back to a single logarithm using the quotient rule in reverse. So for example 4, we want to write each logarithmic expression as a single logarithm. We will be using the quotient rule in reverse to condense the logs. we can rewrite log base 2 of 18 minus log base 2 of 6 as log base 2 of 18 over 6, which then simplifies to log base 2 of 3. And the same follows for the next example. We can condense the expression to a single log as log base 4 of x minus 5 over x squared plus 9. The last property will be the power rule for logarithms. So let x and a be positive real numbers where a is not equal to 1, and let n be any real number. Then log base a of x raised to the n power is the same as n times log base a of x, where we can write the exponent of the log input in front of the log. Let's try some examples using this property. So we can rewrite each expression using the power rule. Log base 9 of x raised to the 4th power can be written as 4 times log base 9 of x. And log base 2 of 8 raised to the 5th power can be written as 5 times log base 2 of 8. And we can simplify log base 2 of 8 since there is a value that we can raise 2 by to get 8. And that value is 3. So we have 5 times 3, which is 15. And for log of the square root of 3, note that the square root of 3 can be written in exponential form as 3 raised to the 1/2 power. And using the power rule, we can write this as 1/2 times log of 3. And here we have a quick summary of the properties of logarithms that we have covered. So we want to know all these properties since a majority of the time we will be combining them to simplify logarithms. So let's try some examples where we combine all these properties. For example 6, we want to expand each logarithm and simplify. So for log base 8 of x to the 5th times y, since we have a product as the input of the log, we can use the product rule to expand this as a sum of logs. So we have log base 8 of x to the 5th plus log base 8 of y. And then we can actually use our power rule here and write this as 5 times log base 8 of x plus log base 8 of y. To expand the next example, we can start by using the quotient rule. So this expands to log base 3 of 27 minus log base 3 of xy squared. We can simplify log base 3 of 27 because there's a value that we can raise 3 by to get 27, and that value is 3. And we can still expand out the second log. We can use the product rule, so this will expand to log base 3 of x plus log base 3 of y squared. And make sure to put this in parentheses since we have a subtraction sign in front of this. And we can use the power rule here for this log and rewrite it as 2 times log base 3 of y. Now we distribute the minus, and our expression simplifies to 3 minus log base 3 of x minus 2 log base 3 of y. To expand log base 7 of the square root of 7x, first let's rewrite the radical as the quantity of 7x raised to the 1/2 power. And now that we have an exponent for the input, we can use the power rule and write this as 1/2 times log base 7 of 7x. Then we use the product rule for log base 7 of 7x, so we can write this as log base 7 of 7 plus log base 7 of x. And be sure to include parentheses since the entire expression is being multiplied by 1/2. And finally, we can simplify log base 7 of 7, which is just 1. Distribute the 1/2, and we have 1/2 plus 1/2 times log base 7 of x. Let's also try some examples where we write each expression as a single logarithm. So for the first example, we want to use our power rule in reverse to rewrite this as log base 7 of 5 squared plus log base 7 of 2 cubed. This then simplifies to log base 7 of 25 plus log base 7 of 8. And since we have a sum of logs, we can use our product rule in reverse to rewrite this as log base 7 of 25 times 8. And this then simplifies to log base 7 of 200. We can do the same thing for the next example. First, let's apply our power rule in reverse. So we can rewrite this as log base 6 of x raised to the 1/2 minus log base 6 of x squared plus 1 quantity cubed. Now that we have a difference of logs, we can use the quotient rule in reverse. So we can rewrite this as log base 6 of x to the 1/2 over x squared plus 1 quantity cubed. And we can just rewrite x to the 1/2 power as a radical.